At first it looked like a routine observation, a tiny galaxy, extremely distant, almost invisible. Then James Webb looked closer, and the light coming from it revealed something astronomers were not expecting to find in the early universe. It was far too bright, far too massive, and possibly far too old. According to our understanding of cosmic history, objects like this were not supposed to exist yet. But Webb kept finding them. Galaxies that appeared surprisingly mature only a few 100 million years after the Big Bang. And the deeper scientists looked, the more uncomfortable the question became. Were these galaxies really breaking the rules of cosmology? Or were we misunderstanding what we were seeing? Because hidden inside those ancient points of light may be one of the biggest problems James Webb has uncovered so far. The story begins with a simple idea. When we look far into space, we are also looking back in time. Light takes time to travel. So when a telescope observes a galaxy billions of light years away, it does not see that galaxy as it is today. It sees it as it was when that light began its journey. James Webb was designed to look farther back than almost any previous observatory. Its infrared instruments allow it to detect light stretched by the expansion of the universe. Light from the first generations of stars and galaxies. And scientists expected the early universe to look very different from the universe we see today. Young galaxies should have been small, chaotic, still assembling. The first billion years after the Big Bang should have been a time of rapid construction. Gas collapsing, stars forming, small galaxies merging into larger ones. But then Webb started sending back images of something unexpected. Galaxies that appeared large, bright, and surprisingly developed. Some observations suggested that only a few 100 million years after the Big Bang, certain galaxies had already accumulated enormous numbers of stars. At first, the reaction was cautious. Astronomers know that distance can be difficult to measure. A galaxy that looks ancient might actually be closer. Dust can alter its appearance, and different types of stars can produce similar signals. So early observations were treated as candidates, not proof. But that was only the beginning. To understand the mystery, astronomers needed more than images. They needed spectra. A spectrum breaks the light from an object into its different wavelengths. And hidden inside that light is information about its distance, composition, and physical properties. It is one of the most powerful tools in astronomy. When Webb began confirming distances for some of these objects, several really were extraordinarily far away. They existed during the universe's earliest chapters. And some appeared much brighter and more massive than many models had predicted. That was the first major surprise. But brightness alone was not the real problem. The problem was what brightness seemed to imply. More light can mean more stars. More stars can mean more mass. And if some of these galaxies contained large populations of stars so early, then those stars must have formed with incredible speed. That raises a difficult question. How did they grow so fast? Under the standard picture of galaxy formation, structure develops over time. Small concentrations of matter pull in more material through gravity. Gas cools. Stars form. Galaxies merge. The largest systems gradually emerge. But some early Webb observations seem to show galaxies that had skipped several steps. As if the universe had started building cities before it had finished building villages. For a moment, it seemed possible that Webb had found galaxies older or more developed than our models could easily explain. And that is where the story became much more interesting. Because the first interpretation was not necessarily the correct one. Several of the most dramatic early claims depended on estimating the masses of galaxies from their observed light. And that process is not as simple as it sounds. Astronomers cannot place these galaxies on a scale. They infer mass from brightness, color, spectra, and models of how different populations of stars evolve. Change the assumptions and the estimated mass can change dramatically. For example, a galaxy dominated by extremely young, massive stars can shine much more brightly than an older population containing the same total mass. Strong emission from glowing gas can also make a galaxy appear brighter in certain wavelengths. Dust can complicate the picture even further. And the first stars may not have behaved exactly like the stars that dominate nearby galaxies today. So perhaps the galaxies were not impossibly massive. Perhaps they were simply producing light in ways our initial models did not fully account for. But that explanation created another mystery. If early galaxies were forming stars with extraordinary efficiency, why? What conditions in the young universe allowed some of them to become so bright so quickly? And Webb did not find just one strange object. It found a population. A growing collection of early galaxies that forced astronomers to re-examine their expectations. The biggest revelation was not that cosmology had suddenly been proven wrong. It was something more subtle. James Webb had exposed the uncertainty hidden inside our predictions. The standard model of cosmology remains remarkably successful. It explains the large-scale structure of the universe, the cosmic microwave background, and the overall history of cosmic expansion. Webb has not simply overturned that framework. But galaxy formation is messy. It depends on processes that are much harder to model. Gravity brings matter together. But stars also change their surroundings. Radiation heats gas. Supernova explosions can push material outward. Black holes can influence the gas around them. And dark matter forms the gravitational scaffolding in which galaxies grow. Small changes in how these processes interact can produce very different galaxies. That means the mystery may not be that the universe is impossible. The mystery may be that our simulations have underestimated how quickly the first galaxies could organize themselves. But then Webb found another complication. Some of the earliest galaxies appear to contain surprisingly large amounts of heavy elements. Elements heavier than hydrogen and helium are created inside stars and spread through space when stars die. In the earliest universe, there should initially have been almost none. So when astronomers detect chemical enrichment in very young galaxies, it tells us something important. Stars must have already lived and died. Perhaps several generations of stars formed in rapid succession. The early universe may have been evolving much faster than we once imagined. Not necessarily older, just more efficient. And this is where one of the most intriguing possibilities emerges. The first galaxies may have been fundamentally different from the galaxies we know today. Their stars may have formed under extreme conditions. Their gas may have been denser. Their star formation may have occurred in intense bursts. Instead of slowly growing into modern galaxies, some systems may have experienced violent periods of rapid assembly. For a brief cosmic moment, they may have been incredibly efficient at turning gas into stars. If that is true, then Webb is not revealing a broken universe. It is revealing a universe that was more extreme than our simplified models had anticipated. But the mystery is not over. Because some observations continue to challenge astronomers. How common were these unexpectedly bright galaxies? Were the earliest estimates affected by selection effects? Are we seeing the most extreme survivors because those are the objects easiest to detect? Or is there a vast population of even stranger galaxies still hidden below Webb's detection limits? And there is another possibility. Some distant objects that initially appeared to be ordinary galaxies may contain rapidly growing black holes. A black hole itself emits no light. But matter falling toward one can become extraordinarily hot and luminous. If an active black hole contributes to the light we observe, it can make a distant object appear more massive or more mature than it really is. That could explain part of the mystery. But not all of it. The emerging picture is becoming more complicated. Some early objects may be massive galaxies. Some may be experiencing extreme bursts of star formation. Some may contain active black holes. And some of the earliest interpretations may simply need revision as better data arrives. That is not a failure of science. It is exactly how science is supposed to work. An observation creates a problem. A possible explanation appears. Then better measurements test it. And James Webb is still collecting those measurements. What makes this discovery so fascinating is that the telescope was not necessarily supposed to find a single forbidden object. Instead, it found something more unsettling. A region of cosmic history where our expectations were incomplete. For decades, astronomers could only glimpse the earliest galaxies as faint, blurred signals. Webb changed that. Suddenly, the universe's first billion years were no longer hidden behind a wall of technological limitation. And almost immediately, the young universe looked stranger than expected. Not magical. Not impossible. Just unfamiliar. The galaxies may not be breaking the laws of physics. But they are revealing that the path from the Big Bang to the modern universe may have been faster, more violent, and more complex than we imagined. And perhaps the most important question is still unanswered. If galaxies could grow this quickly so early, what else was happening in the darkness between the first stars and the first great cosmic structures? How many objects are still waiting beyond Webb's current limits? How many early black holes are hidden there? How many galaxies formed, merged, and disappeared before their light could ever reach us? James Webb was built to see the ancient universe. But the deeper it looks, the clearer one thing becomes. We did not know what the ancient universe was supposed to look like. We only thought we did. And somewhere in that first darkness, beyond the galaxies we have already found, the next observation may reveal something even more difficult to explain.